My name is Polina Rasskazova. The topic of my report, S3finder, fast pipeline for search for unique sequences in genomic data. We propose an approach to development of PCR detection systems using the Ectobacteriaceae family as an example. These phytopathogens cause significant harm to potato growing. They parasitize on potato tubes and causing soft rot, and on potato stalks causing black leg. Due to this disease, up to 50% of the crop per year can be destroyed. This brings great economic losses. There are several methods for dealing with these pathogens. One of them is phage therapy, which features a high specificity against the target pathogen. Bacteriophages infect bacteria in a restricted spectrum. They can be active against one species, and sometimes even only against one or several strains. This method requires rapid species-specific detection of a bacterial pathogen. Since it is necessary to understand which phage cocktail is suitable in this particular case. At the moment, Ectobacteriaceae is being actively investigated, which is why more and more new species are being discovered. The slide shows the phylogenetic tree of one or the genera of this family, Ectobacterium. For this species, 30 out of 90 species have been described over the past few years. It also became clear that not all strains were attributed correctly. For most species, either there are no diagnostic systems or they give many false answers. Also, we need to make new diagnostic systems. How to find a region in the genome that will be specific to a particular species? Now the search for such site is carried out manually on the basis of the unit gain in the household, which makes the process long and laborious. More and more, there is a possibility of making a mistake. Since at the moment, a huge amount of whole genome sequencing data has accumulated, we offer an automated sequence search for species-specific detection based on genome-wide sequencing data. This search is performed on the basis of an algorithm that consists of 3 stages. Stage 1 is preparing. All genome of the studied organism are collected and divided into 2 groups. Positive group only with stains of the studied species, negative group with all other strains of this genus. Then databases with the collected sequences are created, and the target genome to be used for comparison is sliced into a set of short sequences. Stage 2 is finding. The negative database is compared with the target genome to identify sequences that do not resemble the negative group. The resulting fragments are compared with the positive database to find sequences that are specific to particular species. And 3rd step is analysis, mapping selected sites on the target genome and creating PCR primers. This algorithm was implemented as a Python program. Now I will tell you in details how it works. Also, at first stage is preparing. To implement the first stage, it is necessary to submit the following, but to the program input. The program input includes taxonic affiliation to the bacterium, its genus and species, and type strain number of the required species. You can also specify the number of the strains of those genomes that are not classified correctly in the NCBI, so that the program will transfer them to the required database. The program will automatically make two folders with introduced species and with all the other genome that are for the student family in the NCBI database. This slide shows the next step in the preparatory phase in slicing the target genome into short fragments. To do this, you need to give the program a file with a sequence, the desired length, example 100 of the fragment, and the step, example 10, with which the executing will take place. And you can also pass to file with result. This slide shows an example of this program. We see here the original genome, and here the genome that had been sliced into 100 nucleoside sections in 10 nucleoside steps. The second stage is binding. It is carried out in 2 steps, but one program is used for execution. At this stage, S3finder receives as input the data obtained as a result of preparatory operation, a set of short fragments of the target genome and the database. The target genome is a ligand against the selected database. The matched sequences are written to the file with the result. Then 2 new files are formed, hits and no hits. The hits file contains fragments that match the database, and no hits file contains fragments that do not match the sequence in the database. After comparing the target genome with a negative database and obtaining the information about the sequences unique to the target genome was obtained, and they are written to the no-hits file. The next step is to compare this file with a positive database. At the end of the second stage, a file was obtained with sequences that are unique only for the target species. During execution, information about the work done is displayed on the screen. Here you can see the total number of sequences found. Here's the number of matched sequences, and here number of unmatched sequences. This slide shows the result of the program's work with Lectorium parmentieri. After comparing the type strain with the negative base, we get a file with mismatched sequences, which are compared with the positive database. Here we get a file with hits, and it is contains species-specific region of the genome that can be used to create PCR primers. The third stage is analysis of the result obtained. In the second stage, the program first finds all overlapping areas in the plastic ligament file. The slide shows the diagram. This is target genome, and this is the unique sequences. Some of them are single, and some have overlapping. We are interested in the later. Here I show how easy it is to launch this part of the pipeline. You just need to specify the input file. And here is an example of the output file. The arrow points to the coordinates of this site in the whole genome. This is coordinates. Also, With the assistance of S3finder, it is possible to obtain information about the region in the genome that are unique for certain types of bacteria, simple and fast. Now the pipeline is a set of separate programs. In the future, we plan to design the algorithm as a whole. We plan to improve S3finder and make the program convenient for anyone to use, so that researchers who don't have ability to the bioinformatic tools can also select primers for their object of research. Thanks for attention.